Okay, as you go through and do this practice test, please make sure you're showing your work for each one of the problems, even if you think it's something you can do in your head. We really want to avoid silly mistakes, and I really need to see when I correct your test, I really need to see that you understand inverse operations, how to solve these, and show your work the right way. So please make sure you're showing your work, and then remember, if you've got time, you can always double check and make sure you got the answer for the equation, because you can plug it in and make sure it makes the equation true. And then as always, make sure you circle your answer here. Okay, so I'm going to blow this up, and we're going to take a look at basically one problem at a time here. So we start off with kind of a difficult one. This one has that horizontal fraction bar. So remember, we're going to isolate the variable term. Well, this is the variable term right here. So we remember that that fraction bar is a grouping symbol all by itself. So we're grouping these two on the top together. So the first thing we need to do is we need to get rid of that dividing by 2. So we're going to multiply both sides by 2. I'm going to use parentheses to show that implied multiplication around the second factor in each one. Those are going to cancel to be 1, so we end up with a negative 1 plus m on this side, and then we end up with 8 over here. All I need to do to get the variable by itself now is just add 1 to both sides. So we get m on this side and we get 9 on this side, and I circle that. I've shown my work and I'm all set to go. Alright, let's take a look at this one. Variable term is right here, so we're going to isolate that. We're going to get that by itself. We're going to do that by moving that negative 1, so we're going to add 1 to both sides. So these cancel to be 0, so I'm left with x over 4 here. And then when I combine those, I end up with a negative 2. Then we're going to multiply by 4, because we need to undo this dividing by 4. So I'm going to multiply both sides by 4 here. Again, use the parentheses for implied multiplication. Divide, so those cancel to be a 1, so I've got a 1x, which is what I want, and then multiply these together and I end up with negative 8. So there's our answer on that one. Okay, let's take a look at number 3. Here we go on this one. Regular old two-step equation. Here's the variable term. I need to get rid of this 4, so I'm going to add 4 to both sides. So this is a 2n over here because those cancel to be 0. And then combine those, I end up with 6. I need to cancel off that timesing by 2, so I'm going to divide by 2. Cancel those to be 1, so we get a 1n over here. And then 6 divided by 2 is 3. Circle that and we've got our answer. Again, you can always plug it in and make sure that that works. Here's number 4. Here's the variable term, so we're going to leave that alone. We're going to isolate it by getting rid of the subtracting 3. So I'm going to add 3 to both sides. So we get m over 7 equals, let's see, negative 6 plus 3 is going to be negative 3. Difference is 3, bigger one's negative. Okay, and then we're going to undo dividing by 7 by multiplying both sides by 7. So we'll multiply both sides by 7. Those are going to cancel. We end up with an m over here and a negative 21 on that side. So there's our answer to number 4. Let's look at number 5. Let's see. Here's our variable term right here. We want to get rid of that 5, so we're going to subtract 5. Cancel to be a 0, so we have a negative 4p. That's the only thing left over here, and this is a negative 36. Go ahead and divide by negative 4. Cancel to be a 1p, and then over on this side, that's going to be positive, and 36 divided by 4 is 9. Go ahead and circle that one. Alright, this is the first one we've run across where there's variables on both sides. So again, there are 2 ways to do this. You can move either one you want, but it's always a good idea to move the smallest one. By that we mean the one that's most negative, the one further to the left on the number line. So we've got a 2a and a 1a. I'm going to move that 1a, so I'm going to get rid of that by subtracting an a. That leaves us with a negative 13 plus a equals negative 8, because those cancel to be 0. So that means all we need to do here is just add 13, and we end up with a equals 5, and that's it. Alright, variable on both sides. We want to move the smallest one. We've got a choice between a negative 1n and a negative 5n. Negative 5 is further to the left on the number line, so we're going to add 5n. And notice what this does for us. When we combine these, we have a positive 4n. So there's that positive coefficient that we were looking for, so that's always nice. Regular old two-step equation, so I'm going to isolate that variable term by adding 6 to both sides. That leaves me with a 4n on this side once those cancel to be 0. And look at this, these also cancel to be 0. We don't need to panic, this is totally fine, we haven't done anything wrong. We're going to divide both sides by 4 to undo that multiplying by 4. Those cancel, and then again you've got to think, what is 0 divided by 4? 0 divided into 4 pieces is still 0, okay? You can have a 0 on the top, you can't have a 0 on the bottom. Alright, again, 3k over here, negative 6k, both sides are simplified, so we're good to go here. I'm going to move the smallest one. We're going to add 6k to both sides. Negative 8 plus, this is going to be 9k equals 1. So two-step equation, we're going to isolate that variable term. So 9k, and this is 9. Boy, this works out nicely here. Take a look at this. Once those cancel, we get a k equals 1, so we're all set there. Okay, let's go ahead and flip the side over. Back side of this and the back side of the test are probably a little bit more difficult, so let's be careful here. Variable on both sides, but notice that the only constant here is this one right here. So even though this is the smaller of the two, it's actually a better move to add the 4v to both sides, because that will cancel out. We're left with a negative 8, and then this is going to be a negative v, negative 1v. So we're nearly there. We don't want negative v, we want its opposite, positive v. So we don't want negative 8, we want its opposite, positive 8, and there's the answer. Really quick if you do it that way. I mean, you could move the negative 5 over by adding 5v, but then you've got to move the 8. Just a much longer process. Alright, let's go ahead and simplify this side by distributing. Regular old two-step equation. Here's the variable term, so let's isolate that. Those combine to be negative 30, and let's get rid of that multiplying by 6 by dividing by 6, so we get y equals 5, negative 5. Alright, let's see, distribute here. 192, big number there. Let's see how this works out. 32 here. Careful with this one. This is not just negative 5x. We have to multiply by the 8, so this is negative 40x. Isolate that variable term. 160 equals negative 40x. Divide by the negative 40 to undo that multiplication. So we get x on this side. Answer is definitely going to be negative, and then remember you can cancel the zeros, so we're just doing 16 divided by 4, so that's going to be negative 4 for the answer. Alright, number 12, distribute. Careful with the negatives here. This is negative 4. Negative 4 times 1 is negative 4. Negative 4 times negative 6p is positive 24p. Got to make sure you get that sign right, otherwise there's going to be problems here. We're going to add 4 to get that variable term isolated. This is negative 96 equals 24p. Divide by 24. And let's see, get a p over here. And answer is going to be negative, and let's think about this. If this were 25, and that were 100, 25 would go into 100 4 times. This is just one less, so that is going to go in there 4 times. Okay, again, no problem if you have to do 24 into 96 and do it that way. Totally okay. Alright, let's take a look at 13 and 14. Let's distribute through. Boy, look at all these 8s. Negative 64x plus 64. Negative times negative is negative times positive is negative. Negative times negative is positive. 8x minus 8. I'm going to move the smaller one. I'm going to move this one. So I'm going to add 64 to both sides. 64x. So we're going to have a 64 over here. A 72x minus an 8. Let's keep solving this. We're going to undo subtracting 8 by adding 8. So that's going to be 72 here and 72x, and lo and behold, whoops, this is going to work out very nicely because those are going to cancel and we're going to end up with a 1 right here. Okay, so we're in good shape there. Last one, distribute through 15x. Multiplying here, we get negative 21. 35 plus 8x. Let's see. I'm going to move the smallest one. 7x minus 21 equals 35. We're going to have to add 21 to isolate that variable term there, so we get 7x, and if we combine these we get 56. Then we're going to divide by 7 to undo the multiplication there, so we get x equals, this would be x equals 8. Okay, now I'm going to shrink this back down just a little bit so that we can take a look at the next couple of examples. It says define equation and give an example, define a variable and give an example, coefficient and give an example, and a constant. So let's remember what these are. An equation is, we'll call it a math sentence that sets two expressions equal. And the key word here is you can't talk about an equation or what an equation is without using the word equal. Okay, so it's got to have an equal sign in it. Okay, define variable. We'll call it a symbol that represents a number. And right here we're going to say usually a letter. Okay. Coefficient. Now remember what a coefficient is. A coefficient is the number in front of a variable. Okay, so we're going to say the number in front of a variable. And to kind of emphasize that, it's implied multiplication. Okay, and then constant. Constant is a plain old number. Regular old number, no variables, nothing weird or anything like that. Now, if it said give an example of each one of these, here's what we're going to do. Here is our example, and then we're just going to point out what each one of these are. So we're just going to make up an equation. Let's say we've got 2x plus 3 equals 4. Okay? So this whole thing is an equation. Make that look a little better. The whole thing is an equation. Now this right here, the x, that's a variable. So we'll say variable. The coefficient is right here. So I'm going to say coefficient. Coef with a period. We'll make that even shorter. Okay, now for a plain old number you can choose from either one of these. Okay, so both of those are constants. Okay, so we've got one example that takes care of all of it. The whole thing with the two expressions that are set equal, that's an equation. Coefficient is the number in front of the variable, and again there's that implied multiplication. The variable in this particular case is an x. It's the symbol that represents the unknown number in this problem. And then these plain old numbers, those are both constants, so that would work just fine there. Alright, last little bit here. It says write an equation that represents a situation, then solve the equation and label your answer. So, Ming ran 18 miles more than Ryan last week. Ming ran 29 miles. How many miles did Ryan run? Okay, so here's the question. How many did Ryan run? Okay, so we're going to say R equals number of Ryan miles. Okay. Ming ran 18 more than that. So if we took how many Ryan ran and we added 18 to that, we'd get how many Ming ran, and he ran 29. Okay, so there's our variable. Here's the equation that represents what happened in the problem. Ming running 18 more than Ryan, and he ran 29, and then we'd solve that. So we're going to subtract 18, so we're going to get R equals, let's see, this would be 11. Okay, so there's the answer to the equation, but let's answer the question. How many miles did Ryan run? So we're going to say Ryan ran 11 miles. Ryan ran 11 miles. There's the answer to the problem. So we've written an equation that represents the situation, we've solved it, and then we've labeled the answer. Okay, last little bit. You bought a magazine for $6 and some erasers for $2 each. You spent a total of $22. How many erasers did you buy? So since that's the question, we're going to say E equals erasers. We could even say number of erasers. Okay, so you went in the store, you bought a magazine for $6 and then some erasers for $2 each. So $2 for each eraser. If you bought one of them, it would be $2. Three of them would be $6. Five of them would be $10, and so forth. And then the total that we spent was $22. I'll be honest with you, this is what I'm looking for. I'm looking for an equation that represents what happened in the problem. If you know what the answer is, that's awesome. What I want is the work and that equation there that kind of supports that, so I can see that you can translate that. That's the most important thing here. So we're going to subtract 6 from both sides. 2e equals 16. Divide by 2, so we get e equals 8. Okay, so that tells us that e equals 8. I bought 8 erasers. It reminds us what we're looking for. E is 8, so 8 erasers. And that's the answer to the problem. All right, review this as many times as you need to. Go through and do another blank copy. Ask questions. Make sure you've got this understood for the test. Okay, good luck.